All right, so we're going to continue talking about inequalities, and we're going to review a little bit of what we've been practicing the last 2 days. And so when we graph an inequality, we can tell if points are solutions if they are in the shaded area, or they can be on a solid line. So both of those things count as solutions. So if it's on a dotted lines don't count. And so number 1 here is actually an old star question, and they've used this question multiple times, just changing the numbers. So it says the graph of the linear equation y equals 3 over 2x minus 1 is shown. Which coordinate pair is in the solution set of y is greater than 3 over 2x minus 1? So what they're telling us here is that they've taken an equation and they've graphed it on the grid for us. And what they're asking us, though, is about an inequality. And this inequality is already solved for y. However, I would still recommend as a first step to solving this problem that you graph the inequality on the calculator. So I'm going to pull up my calculator here, and we're going to go to a graph page, and we're going to delete the equal sign because anytime you type inequalities, you have to pick a relation. And we're going to graph what I have boxed in. So I have y is greater than, remember you press Control equal to get your symbol, y is greater than 3 over 2 x minus 1. And so it graphs it for us, and if you hover over the line, you can tell that this line is actually a dotted line. So the second step to solving this problem is that you should shade on your paper and label the line. And so even though the line here is graphed as a solid line, that's because they were graphing an equal sign. But we care about this inequality symbol, and so color over it in your highlighter. This is really a dotted line, and it's shaded up above, so that's where all of your solutions are. The second step is to plot the answer choices to figure out, or the third step, sorry, plot your answer choices to see which one is in the shaded area or on a solid line. But since I have dotted lines, if it's on the line, it's not a solution. So I'm going to plot A, 0, negative 1. And A is on a dotted line, so it's out. B is 4, 5. That also falls on the dotted line. C is 1, 2. Looks like that's our answer. But let's type in, or plot D. So 1, negative 1, kind of overlaps my letter A there. But it's outside of the shaded area, so it's also not my answer. Okay? So anytime you see something that's already graphed for you, just re-graph it in your calculator and plot your points. Now, we are going to really talk about today some inequalities, word problem inequalities. And so I need you to look at this inequality chart for just a second. This is going to help you get all of the questions right today. We're specifically going to look at the symbol and then the words. Okay. A key word here that you're going to see a lot is at least, but you're going to see all of these words pop up at some point through the word problems we do. So if the problem says fewer than, we're finding fewer than something, then this is the symbol you'll need. And we're going to come back to this as we do the next problem. So keep this in front of you. Number 1 here. Jason is buying wings and hot dogs for a party. One package of wings costs $7. Hot dogs cost $4 per pound. He must spend less than $40. Write an inequality to represent all the possible combinations of X, number of wings, and Y, number of pounds of hot dogs that Jason can purchase for the party. So here we are talking about two things, and we're going to go step by step here. We're going to define our variables, and they actually already did that for us, but I'm going to write it out anyway. X is the number of wings. And so I'm going to underline that. And then it says Y is the number of pounds of hot dogs. And that's here. And they also told us how much each of these things cost. They said that the wings were $7, so I'm going to put that with my pink. And that the hot dogs are $4, so I'm going to put that with my blue and kind of color code it. And then we need to look for our inequality word. So our inequality word is what we're going to find on our pink paper. And our inequality word here is he must spend less than $40. So less than $40. That's kind of how I'm going to start my inequality. Less than $40. And everything that he spends on this side has to be less than $40. So I have 7x, because 7 went with the wings, so 7x. And I'm going to add up the hot dogs, so 4y is less than 40. And that's our inequality. And so how does this help us? We need to look at different order pairs. What are possible solutions that would fit with this? So it says, what does the order pair 3, 2 mean in the context of the problem? Well, 3 is my x and 2 is my y, but 3, this means that he's saying he bought 3 packages of wings. And 2 pounds of hot dogs. Okay, because 3 is the x, and x was number of wings, and 2 is the y, and y is the number of pounds of hot dogs. So we're just matching everything up. And then we want to know, is 3, 2 a possible solution? And we've been doing a lot with the graphs, but I want you to also know that you can plug points into your inequality on a calculator page. So what we're doing here is we're taking 7x plus 4y is less than 40, and we're going to plug in our numbers. So I have 7 parentheses plus 4 parentheses is less than 40. And this first set of parentheses was x, and x is 3. And then the second set of parentheses is for my y, and y is 2. And we're going to plug that in and see if it would work. So I'm going to go to a calculator page. And if I type in 7 times 3 plus 4 times 2, and I just press enter, it tells me 29. Is 29 less than 40? And the answer is yes. The other option is that you could type this whole thing in and then press Control equal less than 40, and it will tell you true or false. So this is a possible option. If he were to buy 3 packages of wings and 2 pounds of hot dogs, then he would be good to go because it's less than $40. And so we're really going to practice writing the inequality, and we're going to check a point to see if it's a possible answer. And you need to be able to write out what that answer means. Number 2. Cameron earns $5 for every A he makes on his report card. He also earns $2 for every B he makes. How many A's and B's does Cameron need to earn to make at least $54? So the first thing is we're going to define our variables, and we need 2 things. I like to use X and Y, and we're talking about two things in this problem. The first thing is we're talking about A's, every A he makes. So X equals the number of A's. And A's get him $5. And then I need Y to represent the number of B's. And B's get him $2. And then I need to find an inequality word. And if I'm looking through here, it says he needs to make at least $54. And if I go to my inequality chart, and I look here, I see the word at least, and at least means greater than or equal to. So that's the symbol I'm going to use. And I'm going to put it at the end. Greater than or equal to $54. Now what's going to get him that much money? Well, all of the A's. So 5x, that's all of the A's because each A is $5. Plus all of the B's. So 2B, oops, I didn't use B, we used Y. 2Y is greater than or equal to 54. So I'm just going to rewrite that again. 5x plus 2y is greater than or equal to 54. And then we need to talk about this order pair. What does the order pair 10, 5 mean in the context of the problem? And is it a possible solution? So first, what does it mean? Well, remember, X is the number of A's. So this means Cameron earns 10 A's, and this is your Y, so and 5 B's. Okay, that's what this inequality means. And then we want to know if it's a solution. So we're going to plug and chug. We're going to plug in X, 10 for X and 5 for Y, and see if it works. So I'm going to come over here and I'm going to show the work over here. So I have 5X plus 2Y greater than or equal to 54. Will 10 A's and 5 B's be enough to get him his money? So 5 times something plus 2 times something. And we're going to plug in our number. So 5 times 10, because 10 was my X value, plus 2 times 5, because that was my Y value. And now we're going to go to the calculator, and we're going to type it in. So 5 times 10, and I'm using the parentheses, plus 2 times 5. And again, you can just press enter, and it tells me that this would get him $60. Is 60 greater than 54? Yes, so that would be a possible answer. The other one, is 6 a possible solution? Well, I want to know what this means. Remember, this is X and Y, so this would mean Cameron earns 6 A's and 2 B's. If he earns 6 A's and 2 B's, would that be enough money? So let's rewrite our inequality. 5x plus 2y is greater than or equal to 54. And let's leave room for our parentheses. And we're going to go back and we're going to plug it in. So x is 6 this time, and y is 2 this time. And let's go type that in. So I have 5 times 6 plus 2 times 2. And that gives me 34. Is 34 greater than or equal to 54? No. So that is not a possible solution. If he wants $54, he needs to make some more A's. All right, summary question. Jeremy bought X notebooks at $1.20 and Y folders at 75 cents each. What does the point 13 mean in the context of the problem?